Hello, and welcome to Golden Droplet, a series of webinars aimed to narrow the distance between the industry and the academy. In today's episode number 45, we will be talking about coreshacks, which are the heart of any company. So, once again, Golden Droplets, episode number 45. Enjoy.
This is a demonstration of the circuit within the coreshack. Okay? The guys will come with the box. Of course, we need to walk from there to here. It's not easy. And then the first step will be to weigh the sample. When they weigh it, here at the front, I have the number of the box, the number of the hole, and the intervals. I will tell that to my geographer, who is taking this note. So it will be box 1 from 0 to 4, it weighs 10 kilograms. Okay? Now, why are we weighting the core boxes? Because if the sample is mineralized, it will weigh more. So even by just this simple step of weighting the core, we will have an idea if we have or not mineralization. With time, when we're going to be doing this for some time, we will already know that a normal box will weigh, let's say, 4 to 4.5 kilograms. So if it weighs more or less than that, these guys will have a sticker, a red sticker, and they put the red sticker here on this corner. So when the geologists will start doing the logging, they will know that this box is heavy, or yellow if it is light. Okay? So that way we will have this information. That is why it's so important to weigh the sample. Then we pick up the box and we put it here with the number towards, the number towards here. So the next step is to do the RQD, which is the rock qualified definition, which we cannot do because this is just plastic. But as I mentioned, there are plenty of videos on YouTube that you can check how to do it. Basically, it checks the amount of core that is not broken. Usually, when the drillers make the hole, they make the hole for 3 meters length. So we will do the RQD every 3 meters. And we just determine how many of those 3 meters, how many centimeters are broken, how many are broken, how many are very, very broken. And with a little formula, I sent yesterday Kunle a graphic with the formula, and that graphic is in the Excel file that you receive for the portfolio. You do the estimation and you get the portion. The other thing that we do is to measure the recovery. Normally, it would be great if the driller will recover the 100% of the core. This is 1 meter, okay? So, but that never happened. So, what you do is you take a measuring tape and you measure the length of the core and compare to the information that the drillers put. They put little wooden stocks here, saying, for example, this is 0 to 1, and yes, this is 0 to 1, this is 1 meter, 100% recovery. But this one here is 1 to 2. When you measure this thing, it's 80 centimeters, so it's 80% recovery. So you do that thing. Once you have done this, then we go and do the quick logging. For the quick logging, you take the box again, and you bring it here. Now, geologists. So, you need to do a very quick logging of the core. The objective is to determine the lithological units in the rock, because we will do the sampling within the limits of units, of geological units. Okay? Sample will be usually meter by meter, but within those limits. So, as I always mention, especially in tropical countries like Africa, we have a good lateritic soil, usually. So the first thing you come and see in the core, you're trying to locate the stone line, okay? Or the mottlet zone, okay, which is within the stone line. It's a place where you can see white, yellow, red. It's like a mix of colors, okay? That part is the marker. Anything above that is the limonite. Anything below that is the saprolite. And below that, if it has some kind of like a putric rock, that is the sap-rock. Okay? After that, it becomes the fresh rock or bedrock. So you just, in your quick log, you start marking these points. Okay? The quick log will start from 0 to 50. We will do this in detail, okay? In a separate thing. So once you have an idea of the limit, then you take core by core very carefully, okay? And you're going to put it here. This is our core orientation, okay? So take it. And you just try to make it fit, because the core never breaks like this, it breaks irregularly. So you try to put it together, okay? So that's it for the time being. Now, once you have the section of the core put in there, we need to find the cut line. And this line must be perpendicular to the structures. Okay, here at the beginning, this is clay, by the way. You're going to cut this not with a machine, you're going to cut it with a cutlass or with a wooden knife. Okay? So this is very simple, and it doesn't matter how you do it because it has no orientation. We are expecting to cut a lot of green schist, and green schist has a lot of orientation. If we are really good and we orient the core properly, that orientation will be flat, which will be perfect, but nobody's that lucky. There will be some orientation. So what you're trying to do is to find a line that is more perpendicular to most of the rock. Okay. But if you have like a quartz vein, like here, then you will try to orient, to cut that vein perpendicular, because with the best goal will be in the quartz. So you start playing around, okay, you know, okay, here is perpendicular, okay. I already drew this line yesterday because this is the second time we do it. So we orient it, and when we are satisfied with the orientation that we have, then we rotate here to the side, okay, and then with the marker, we just go and do the marking along the road, okay, and that perpendicular line in black, that is the cut line, okay. So then we put back this on the core box with careful. Okay, so now we know that is the vertical line. Okay, next we need to define the sections for the cutting, and for that we're going to use a blue marker. Again, we have here a quartz vein, very good quartz vein, okay? So that will be on its own a sample. Okay? Here we have a quartz vein, but that is a very small quartz vein. So we are not taking that individually because it will not generate the necessary weight for the sample, okay? So that will be part of the interval, whatever it will be. This first part is also a lithological unit, you know, the soil. So I will sample this, so that's the blue line. Then I will measure 1 meter until I get to here. That will be the second time. Then I measure another meter until I get to here, third sample. Then whatever is this distance from here to here, that will be a sample. Okay. then from here to whatever. That would be the other side. Okay, perfect. Now, once this is done, the guys that carry the cord, they will take the box and they will go inside that place. Okay, we are not going to go because anyway the machine is not there. But that is the next step. We go into the place where they do the cutting. They cut the cord, and that is where Tulu
and the meta.
okay. When the cutting machine will be here, we're going to have a film of this later when the machine comes. But just to explain, the guys will cut the cord. Tulu, you will take 1/2 of that cord and prepare your sample. And you will have here a list of which sample correspond to blanks, duplicate, and standard, so you will never forget. Okay? So you prepare the samples, you put it in a bag, we will film that tomorrow, okay? And that's it. The other side, when it is cut, we go to the page, photograph page. So, no, it's the other way around. This is the bottom. This is the photographic station. We need to glue this, with Scotch tape or whatever, because it's bending. Okay. So the camera needs to be at an angle of 45 degrees with the cord. Once we have this done, we will mark in the floor the position of the legs. Okay, so it will be fixed and will never change. We take the picture. The picture will include a color scale, and here we need to have a plastic white thing, but you can write with not permanent markers, the number of the hole, the number of the box, the date, and from to. So that information will be also in the picture. And this thing here, that should be a ruler. Okay. We can paint it in white and put the number, so we can just buy a 1 meter ruler and put it there, which is better. Okay. So once this is finished, and you see how many steps this has, this is why we need to play this like a ballet, so it will not mix. So the next step will be the actual load. So again, you take the cord, which is half now, and you put it back here. And we will go through the logging in the next video. So, stop. We're going now to talk about the actual logging of the core. The logging of the core is a multi-step process, and each step is each one of these little pages that I send you in the portfolio of drilling. So the first thing we do is we do a quick logging, which we already did. I mean, we didn't log it, we didn't write it, but we defined the main structure. So now the first step is to write it down. So here you have a little column with the scale, so you can make a graphic of what you're seeing. Okay, so you can start, and you do it of course with a pencil and have an eraser by hand. And this is what, 5 meters?
5 meters.
So this will be 1 meter. So of course we are working on this upper little part here, very close to the surface. So the important thing here, when you have a situation like this, that you cannot have the detail. What is the most important here? That one thing, maybe this little one. So try to figure out where is 2.7 and make a little vein, and 3.2 and make a big vein. So that is what you draw in that column. But then you write in the text the normal text. So you have the limonite, the stone line, the saprolite, the saprock, green schist with the quartz veins, etc. Now, the only thing, if you have the computer on, you have the computer here, the only thing that you need to do with your clipboard is the graph. The rest, type directly into the Excel field. It's one less step, one less chance to make a mistake. So, as I said, this is the first pass that you do, and you do that for the whole core. Then, after that, you're going to describe different aspects of the core, like weathering. And weathering will only be only the first meter. Unless here, the alteration. We spend a lot of time talking about the alteration. We are talking about hydrothermal alteration. And all the steps that we did for naming the rock, it's the same thing that you're going to be using here. You see that there is space for the links. Links are the apostrophes, etc. So, as I mentioned, we have logging, the quick log we have from 0 to 50, from 50 to 100, to 100 to 150, and from 150 to 200, because we don't have any holes deeper than 200. If we had, we still have more of this. Okay? Then we have the log form A, which is very simple. The from to, the lithology, the description, the color, link color, texture, schistosity, falling, and shear. Shear we have, especially in the green schist we will have it. A schistosity also, okay? In this case, you just make it like a mark. We have it, okay? In the description, one thing, this is very important. Logging is a science and it's an art. You need to be very descriptive. You take your time. Sometimes a geology can take an hour to get through one box to another. Take your time. Nobody's going to pressure you. But for the resource estimation, we don't need that kind of detail. For us, in a resource estimation, doesn't matter if it is a quartz-rich diorite, or a diorite, or a granite. No, all that is falsified. So, at some point in the lithology, this one here is the simplest lithology that you can have. Okay, so green schist, amphibolite, or felsic rock, we don't know. Okay, that's the form A. The form B, and I should put my glasses and stop pretending that I am a young guy. Okay, now the whole from two structures. If we see a structure, alpha. What is alpha? We don't still have the goniometers. Okay, the goniometer is like two rulers. Imagine two rulers, one on top of the other, and one can open and close up to 90 degrees. And here you have an angle. So the alpha angle is the only one that you can measure when the core is not oriented. Okay? And the alpha is the natural surface which the core will break. And if this was rock, this thing, it will break like this. Okay, so you just measure that angle here, which apparently there is almost, let's say, 45 degrees. So that is the alpha angle. So you measure the alpha angle, measure as many as you want. Okay, this is very important. Fillings, if there are fractures, have filling. Quartz or carbonate. So always have your acid with you and test it. Okay. The thickness of the filling. If you see movement, if the core, you can see that there have been there was a vein like here and then a vein over here. Measure this movement. The surface, if it is a flat surface, and the color. And this is very important. This part here defines a project, really. The fracturation per meter. Because there is a structure on top of every granite, which is called the stringer zone, So it's a series of valence, of thermal valence that come from the ore body into the ore, and that is usually one of the best parts for mineralization. And you define the presence of a stringer in a core, because you cannot see it in the surface, by determining how many fractures you have in the meter. Okay? Sometimes you cannot count because there are plenty. Okay? So you just put more than 100. Okay? But if there are like 5, 10, if you can count per meter, you count it. Because that is, we are looking for fractures and fluid that came later into those fluids. Okay? Then, alteration. And again, use the codes that I gave you for all typical type of alteration like argillitization, advanced argillitization, propyllitization, etc. Okay. So from to alteration, link, alteration, link, alteration, link, alteration. You have for four alteration combination per interval. Okay. So remember, if you use a semicolon, that means something that starts with one alteration and ends with another alteration. A dash, it means that it has both at the same interval. And you should use the code, like P pervasive, V mainlet, etc. Okay? You can practice, and it will be very good if you practice doing this thing. Imagine yourself, okay, if I have this kind of rock, write it down, so you will know how to do this thing. Mineralization, same as the other one. You look wherever it is mineralization, you describe. From to what type of mineralization, link mineral. For example, you may have oxidation by pyrite, okay? Or you may have pyrite, chalcopyrite, gold, and diamonds, okay? So you describe this, the mineralization. Veins, again, you have that vein or that big vein. You describe it from to what mineral percentage, what mineral percentage, because for example, here let's say it would be 90% quartz, but you have 5% pyrite and 2% chalcopyrite and 3% bornite. You may have that thing, okay? So you put the mineral at the percentage. We don't have, for the geophysical measurement, we don't have it, but we will order a capometer. And the capometer is very easy to use. You just press it and it gives you the magnetic resistivity of the thing. A capometer. You will have a radiometer or a spectrometer to measure the amount of uranium, thorium, potassium, and the total amount. Another thing that you have in your pocket is your phone. It has not a capometer, but a sensor. It has a magnetic sensor, okay? So you can test with your magnetic sensor. It's not top of the line, but it's an additional information that you can have, okay? So those are for your physical measurements. Then these are the results from the lab. When we get the result, we just write it there. And this is, of course, this is not in the proper order. The proper order is that one is, okay? So you will do, one of you will do audits of the driller, because we need to get on the driller step foot all the time, because if not, they will start doing that work. That's the nature of this. So these are the points that you need to check when you do an audit of the lab. Yes, no, observation, and you discuss the results with the driller, because they are not the enemy, and we are not the enemy. Okay? But they need to know that they are doing a good job or bad job. This here is the legend of everything that we are going to be using here. So let me start again by the beginning, which I should have started here. As I mentioned, this is the portfolio, and every hole will have one. You have here the number of the hole, orientation, the project, who did the logging, when it started, when it finished, what are the planet coordinates, what are the surveyor coordinates, because as I mentioned, I gave you a list of the coordinates. But when we got into the field, we saw that where I wanted is not exactly that it's best to go 10 meters that way. You do it, but you then write it here. And every time you finish one of these pages, just mark it. Okay? So the first one, which we actually pick this one here, is the drilling request, because we need to define why we want every hole. What are the objectives that we are looking for with that hole? Okay, so we plan, we give it to the boss to sign, we write what is the objective, and we make a little design of what we expect to find in that hole. This you need to give to the drillers, okay, before we start. Sometimes we don't have no information, we don't give nothing. But for example, we are doing a lot of double holes at 45 and at 60 degrees. So when we have the geology of the 45, very easy to assume what will be the geology of the 60 degrees. So we make the plan and we give it to them. Most important for them, for the driller, is to know where is the water table and where are the potential faults or contacts between different rocks. Okay? And again, expected major intersection, in this case is the water table, we expected at 5 meters. The next page after this is the photographic record. And we take, from each hole, we take 4 pictures. Before the drilling, during the drilling, after the drilling, and the recovery of the platform. Because sometimes the driller left a mess behind. We cannot allow that. They need to let the thing clean up. And what else? This is the weight of the boxes. I explained why it's so important to have the weight, the core type by boxes, because we are going to be drilling 2 size, HQ and NQ. NQ is HQ for the beginning, thicker, and then it goes to NQ, which is faster. Then the sampling control, this is Tolu. Okay, all your samples that you're going to have, this is a duplicate, this is a regular sample, this is where you write it down. And then the RQD, which I mentioned to you, and that's it. The rest we already. So there are many ways to do the density determination. The best form or the best way is to have a scale that you can hold in your hand, or make a nail hole here, and then it should have some kind of a disc, okay, where you put the sample. So you take the weight and then you put that into a bucket of water and you measure the weight under the water. So it will be less because it will float the density. So density will be the weight in the air divided by the weight in the water. Very simple. What is the problem with that? Is that if the rock is porous, okay, then previously to doing that, you need to submerge the piece of rock in paraffin wax, because wax has the same density as water, so it will not affect the density of the rock. You wax the whole thing, so it will not be porous, and then you do the thing. Okay, so that is the easiest way and the best way. Now, for that we will need, as I said, a scale that you can put in the air and put it inside the water, and most important, the disc, where you're going to put the rock and then put it inside the water. So this is where geometry comes to work, and you all asked when you were a student, why in the hell I need to learn geometry? I will never use it. Here you're going to use it. Let's assume we don't have a hanging scale, okay? But if you get a piece of core, you can determine the volume of this piece of core very easily by geometry. The diameter by P, P by 2 times the radius by the length, that will give you the volume of this piece of rock. And then you just weight. Weight by volume, you have your distance. No problem with porosity, no problem with nothing. So, with a red marker, remember we have the black for the center line, the blue for the intersection of lithology. With a red marker, you will mark approximately a piece like this, like 10 centimeters, okay, of the core. And when the guy that is working at the coreshack will see that red line, he will cut it for us. Okay? And then, how many times? As many times as you want, because as many density is good. But most important, every type of lithology must have its density, at least one. So for example, in this box, we will have one for the quartz and one for the green schist. We will avoid this part here because that is a mix, okay? So in this box, we will have 2 rocks for density. Again, the formula, I just sent you this morning an updated version of the portfolio because I added the recovery and the density, which were not there the first time. So remember the formula, P 3.14 multiplied by the radius, which is the diameter by 2, squared by the length. That gives you in centimeters, that gives you the volume in cubic centimeters, and then you go weigh the rock, gram per cubic centimeters, done. No, any questions? It's in the paper. P, which is 3.14, multiplied by the radius square, and the radius is the diameter divided by 2, multiplied by the length of the core. So again, that's the radius, half the diameter, that's the radius, so it's P 3.14 multiplied by radius squared by the length. Perfect.
3.142.
Now, who's going to be doing that? Tolu! Okay? Tolu will be doing the density because the geology will be busy doing their logging. Okay, so you know how to do it. And if by any chance you do one of these measurements and you see a very high value, you tell the geologist. There is something here, or a very low value. Any extremes are good, qualified.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.